Okay, thank you very much to Matt and Angus for inviting me to speak here, and thanks very much to Ventix for the venue and the food. So I'm going to talk a bit today about my startup, DoseMe. So it's been in existence for about 2 years, but the title perhaps could be considered a bit strange. So I'm calling this talk DevOps in a Regulated World, but what I really mean by that is Ansible, AWS, and a little bit of Jenkins. And you'll see why I'm calling it this in just a minute. So as an overview of the talk, I'm going to tell you what DoseMe is and what we do. I'm going to talk a little bit about DevOps and medical devices. It'll sound pretty strange now, but hopefully will make sense shortly. I'm going to give a very brief overview to Ansible for those of you who aren't familiar with it. And then get stuck into using Ansible with AWS. I'm going to then wrap up by giving a little bit of a summary of some of the technology decisions that we've made along the way so far, and the results that we've achieved. So firstly, I'll tell you what DoseMe is. It's a dose individualization tool. It supports iPad, iPhone, web, mobile web, integration into other systems. But we help doctors and pharmacists dose patients with many different classes and individual drugs. To give you an idea why this is important, if you dose a person, or if you dose a child with leukemia individually, rather than, you know, they're the average person in the population, you improve survival rates by 15%. For patients receiving a particular class of antibiotics, you save costs by $2,500 per patient, and the reason is that you get them out of hospital sooner. So currently in hospitals, doctors use a table like this. If they're going to dose you with a drug, this particular one is for warfarin, they look at this table with a whole lot of other drug names and they go, okay, some have more pluses in this column, some have more pluses and are red and are bold, so they must be really bad. Who knows? And so they'll look at that and go, yeah, well, we'd best give them a bit less. How much less? It's a Tuesday, 2 milligrams less. That perhaps is a bit of an exaggeration, but it's not very far from the truth. But there are ways of doing better. So if you were to figure out how much time it took you to drive to work, and it's a new job, how would you do it? You might drive the night before, or you might think a bit about, well, it's 5 kilometres and it's Brisbane traffic, so I'll give myself 35 minutes. If you end up not getting fired, then the next day you've got a much better idea of when to go to work because you've already got data about the previous day. And similarly to this way of figuring out how long it will take you to get to work, we can dose patients with drugs. We don't need to know what the drug is that's affecting the one we're trying to dose them with. We just need to know how much it's affecting that by. In terms of the startup, 2 of us founded it. Now we've got 2 scientific board members, 2 additional developers, a reg affairs officer, and we're hoping to have a funding round finished by next Wednesday, and we're hiring. So just throw that out. What's a medical device? Well, it's anything from radiation therapy machines that will kill you if they're pointed at the wrong place, to a tongue depressor or a paddle pop stick. Right? They're both regulated medical devices. More recently, standalone software, and particularly mobile apps, the FDA is getting very thingy about mobile apps, have been included as medical devices. It varies all around the world. We're not a medical device in Australia, New Zealand or South Africa. We are a low-class one in Europe, but in other parts of the world we're higher classification, and then for the majority of the world we currently have no idea. But the question is, how on earth is all this talk about medical devices relevant to DevOps? Well, medical device guidelines need to cover everything from radiation machines to paddle pop sticks. But there are some core consistent things. You need to be able to trace complaints and features and fixes, and Jira would be, well, it is what we're currently using. But more importantly, you need a reproducible production environment or manufacturing. You need to make sure that when you manufacture your software or roll it out to production, your environment's always the same and that it's always going to behave the same. And so a configuration management system, or orchestration as they're calling it these days, like Ansible, is simply the best way of doing this. In the past, people have used pen and paper and signed off checklists. I'm very thankful I'm not doing that. For continuing to maintain this and keep it in a consistent state and keep bringing production back to a state if it changes, you can again use Ansible. We're then using Jenkins to maintain records of this, just like you would for dev testing. So I'm sure that all of you probably have an idea of what Ansible is, but just to give, I guess, a contrast it to other configuration management systems. Ansible, they call it an orchestration engine aimed at configuration management and application deployment. And you can think of it as like CF Engine or Puppet, except, and while I can't personally speak for Puppet, it's a whole lot nicer to use than CF Engine, that's for sure. It's got a really dead simple syntax, so it's in YAML. What you specify in a handbook is executed in order, so there's no dependency tree that you have to kind of figure out. It's in Python, so if you've got a Linux machine, it's already going to be on there. It's agentless, in that it uses SSH to communicate, so that's one less thing to worry about. I was talking earlier, and I believe that Puppet masterless Puppet deployments are currently the way to go. With Ansible, there's ways that you can do that too, but it's certainly a lot simpler than having to sort out your agent communications. And it's a very popular project on GitHub, and it's backed by a commercial company if that matters for your work. But I guess more importantly is what can you do with it? Ansible's a bit different to some other configuration management platforms in that pretty much everything is in core. So you can extend it yourself, but it has a core set of modules written in Python. And the goal of Ansible Works is that when a module is developed, that it's brought up to scratch and brought into the core set of libraries. Now, this ranges from everything from looking at this very tiny font to setting up SE Linux policies, through to setting SSH keys. But the ones that I've got in bold here are all different Amazon Web Services related tasks. So these range from CloudFormation, so setting up an entire deployment, to EC2 and setting up an Amazon Web Instance, to their equivalent to Memcache, to their relational database service, to setting up DNS and managing your DNS entries. So really, the current state of Ansible is that if there's something that you wish to do with Amazon Web Services, you can probably do it. And this is quite interesting in a way, in that traditionally configuration management has been on servers or virtual machines that you've already deployed. So you have to deploy them, and you have to have some way of managing your deployment of them. And when that sits outside of what you're controlling, you have the potential for unexpected events. But with systems like this, or other configuration management platforms that let you actually manage your entire network of machines, you can actually bring that in, put it under code control in Git, for instance, and have much better visibility of any changes and modifications made. Now, before I get on to actually giving you a little bit of an introduction to Ansible, I figured that I'd best put in a slide about installation. Now, there's I have made a repository available online with some of the code or some of the configuration that's in this talk that you can all check out later. And I'll put these slides in it. But just for this talk, I should make it clear that I'm using the dev branch of Ansible here. And it's currently required for some of the AWS features, but were you to wait about 2 months, they'd have another release anyway, and odds are that stable will be fine. As far as installation goes, you clone a Git repo and you build it and install it the standard Python way. In order to talk to Amazon though, you need one additional library installed in addition to Paramiko and Ginger, which is Boto. So it was originally written by a third-party guy outside of Amazon. The apparently, partway through last year, he's been hired by Amazon and is being paid to continue the development of this Python library. It's an absolutely fantastic library if you want to roll stuff yourself as well. And I've got a link to the docs at the end of the talk. When it comes to using Ansible, I guess the first thing that you need to specify is which host you're going to run actions on. And it's very simple. It's just your standard INI style definition file. On the left, we have localhost in a particular group. Now that's a bit special, and I'll explain why in a minute, although it need not to be. And then we've got two example web servers in the group www. And we also have an empty group called launched. We'll talk a bit more about this later, but launched is an important group in that whenever we actually launch an instance, we're going to automatically on the fly add those new EC2 VMs into that group. As far as running ad hoc commands goes, you can do that very easily with Ansible too. So the ping command makes every server return pong. And you can do that using logical operators. So you can ping all of the web servers, but not the local group, assuming anything in the local group was in the web server group. To put this into practice, we can just come up with a simple ad hoc task and run it across the inventory file we saw on the particular page. So I don't know if any of you have ever been masochistic enough to install SL on any of your machines. Yep, I see some nods. Great way to annoy your co-workers. All you need to do is Ansible all, so you run it on all hosts. Specify your inventory file that lists the hosts, and because you're running Debian or Ubuntu, of course, you use the apt module, packages SL, and the state is installed. Depending on how many hosts you've got, that'll take more or less time to run, but you can be guaranteed that you're going to annoy somebody. But, of course, ad hoc commands aren't how you actually manage a fleet of servers when you've actually got them. So you need to have a playbook that specifies multiple commands, multiple tasks, and a series of plays. As I said before, Ansible executes in order. So there's no dependency graph that it needs to figure out. When you specify install Apache, configure Apache, you can be sure that it will always happen in that order. And of course, you can include other files into your playbook so that you have some element of reuse. This is very much though the older way that you'll see Ansible done. They have a new way that actually lets you not repeat yourself much, much more effectively, called roles. So the idea of a role is that you'll have a role such as web servers, or Django, if you wish to roll that out into production. And that role will encapsulate tasks, variables that are significant, handlers, so a handler is something that happens in response to a task if the task needs to be executed, files, so any files that you're rolling out, and any templates that you edit and roll out. For instance, putting the host name in a postfix config file. You have a pretty straightforward directory tree. And unfortunately, because of the way Git handles directories, you won't see this when you check it out, because I didn't put an empty file in every one. But again, very, very simple. A roles folder containing a folder for each role, which then contains folders for whatever parts of Ansible's configuration you want. In your playbook, then, instead of specifying what you include and what tasks you include on what hosts like you have here, you assign roles to hosts. So in this case, on the right-hand side here, we're applying both the roles common and the web server role to our web servers. I'll also just quickly point out here that Ansible doesn't need to log in as root. It can use sudo. So if you have access control policies in your organization that require you to not log in with a super user, or that require you to, for instance, or that through the use of sudo only allows your department to do certain administrative tasks, you can set up an Ansible playbook and roles so that you can actually do that. As I mentioned before, there's a sample playbook that's available by Git, and I guess we can email that out afterwards. And so this is really the core part of the talk. So I've got some, this particular playbook demonstrates configuring a VPC, so a virtual network on Amazon, with 2 security groups, which you can think of as firewall policies that get applied to servers, if you're not familiar with Amazon Web Services. The playbook then deploys 2 EC2 instances, or 2 virtual machines, inside of the previously defined private network. It then adds the relational database server. In fact, it runs across multiple availability zones. It then deploys a load balancer that talks to both of the web servers, and then installs Apache, Vim, Postfix, Screen, and sudo, because that's the list of packages I pulled out of my hat. In terms of actually deploying that yourself manually on virtual machines, that's going to actually take quite a bit of time. In order for me to deploy that, and I won't give a demo now or during this talk of actually running the playbook, but in terms of actually doing it, once you've got the playbook written, less than 10 minutes. And back from, I guess, the old days before virtualization was even common, at least on Intel hardware, that's such an amazing improvement. Okay, I guess the first thing is that you need to be able to configure Ansible in order to actually have the authority and authorization to create virtual machines under your account. So I'm not going to go into creating an IAM role today. Amazon has plenty of documentation on that. But if you create one, for instance, that belongs to a power user group, you can then download the credentials. There's a few different ways of giving Ansible the credentials for the role. I'd suggest not putting them in version control, but you can add them to a, yeah, somebody's seen that happen before. You can add them to a file in your home directory, or you can even pass them as environment variables. There's a few different ways. This is probably the simplest for talking about it. So now, how do you actually deploy an EC2 instance? Well, you use YAML that looks like this. The first thing to notice is that we call it a local action. So this whole thing is considered a task in Ansible, and the local action says this happens on the server which you are running Ansible on. We're using the EC2 module. So state is the next idea, which I'm sure you're all familiar with. We actually want the servers to be present. If I put destroyed or absent, it would remove the servers. We then have the region, so do we want them in Virginia or Oregon or Sydney? We then have an instance type, so you can pick anything from t1.micro, which falls under the free tier, up to something ridiculously large if you so choose. An image, and then for VPCs, the network that you want that instance to go into. The most important thing when you're first writing an Ansible playbook to deploy onto Amazon is to make sure that you put an ID in there. You don't actually have to, and the playbook will run just fine without it. If you don't put it in though, and you're running Ansible every hour, you're going to deploy a complete new set of servers every hour. Whoever holds a credit card in your organization may be very unhappy with you, particularly if they're large instances. As far as this particular ID goes, there's a ridiculously long document explaining how you can format an ID, but it needs to be unique. You shouldn't reuse it, although apparently you can, but don't. But more importantly, it can represent either one or a set of instances. So back, oh, actually forwards is easier. There's many more fields that you can put in if you want, but you can put count in. So you can actually deploy 10 EC2 instances that are identical at once. The playbook doesn't do that, but it does have the count line there. The next, I guess, thing to look at in this particular set of things, and just for, I should probably have mentioned this before, anything inside double braces is a variable that gets interpolated in there. In the VPC subnet ID, which is saying which network that you've got defined on Amazon do you want your virtual machine to go into, we have this long variable, VPC, so the first object in the subnets array on the VPC and its ID. That's not defined in any of the variable files, so where on earth does that come from? Well, we register a VPC, and again, there's far too much stuff to go in here today, but we've got some net blocks listed there, and some routing tables, and all of the stuff that the network guys usually play with. But at the bottom, we've got register VPC. So every single task in Ansible returns a data object. And that data object contains useful information about that particular task. So it can contain stuff like whether it succeeded or not. But in particular for the Amazon Web Services type of task, you're going to heavily use the results of one task in order to perform others. So when you normally run Ansible, you get some type of output like this. So this is actually a live set of servers for auth and dosing. And these are local tasks or local actions. And I'm provisioning here a VPC in US East 1. If I use the -v flag, which I highly recommend that you do when you, if you develop Ansible scripts, you'll get a JSON data structure printed to screen. So from this, we can see the actual subnet ID here. So this whole object was called VPC. We then have the subnets array, and then that's the ID of the first entry. The most difficult thing, perhaps, that we've found with Ansible so far is they don't necessarily document this for all of the tasks and modules. In many cases, it will be there, but for particularly the newer development branch ones, they'll document all of the options you need to pass, but not necessarily what that task will return. So if you are developing Ansible config management, I highly recommend using the verbose flag. And the other thing too is that I haven't talked about it today, but Ansible, apart from mentioning that Ansible uses SSH, if you have connection difficulties, you whack a few more -v's on there, and you will get incredibly useful information returned to you. I hope that soon the documentation will actually contain all of the return objects, but not just yet. As I mentioned before, we're running from the dev branch, and this is one of the issues even in the dev branch. Ansible, as the official dev branch, does not yet support creating elastic. Yeah.
Yes. It's EC2 ELB.
Yeah.
And that creates LVs.
Yes.
LVs.
Yeah, but not in VPCs.
Oh really?
No.
No, we do it. So.
Are you sure?
Yeah.
You can do them outside of VPCs, and if your VPCs have public IPs, you could probably attach them.
Well, I'm pretty sure we've done them internally in VPCs, but I'll have to double check.
Okay. In any case, it possibly changed recently.
Okay.
Yeah, it's a problem that we've run into in terms of specifying which subnet ID they're in. The library underlying Ansible's implementation of the AWS modules most definitely can support creating load balancers in VPCs. So that is one workaround that you can use for now. And we are working on the patch internally. It is buggy though, so it's got some kinks to be worked out. There are examples of how you do this in the code repository. We'll email that later. But okay, so I guess we're at the point now of where we've created some instances. We've got them in a VPC, we've created a load balancer, we've even created a relational database service, although I haven't shown you the code for that. So now what? We didn't actually have a list of those hosts in our inventory file earlier, we just had the empty host group. So what we need to do then is add the hosts to a host group so that we can then configure them so that they actually provide some useful service. And again, we use the local action to do so. We add all of the hosts in this particular object, so our list of EC2 instances, again returned from the Ansible task. And we add each of their public IPs to the launch group. Now, in terms of connecting to them via SSH, when we created them, we specified the key pair that we're using. So we assume that this box actually has access to the private part of that key pair. And although it was empty earlier, in our playbook, well, at the time of writing the playbook, it certainly was empty. You still assign a role to it. So in this case, it's common. Even though at the time of the equivalent of compile time of reading the Ansible scripts, those hosts weren't in that group, it will still run the common role against all of those hosts that you've just launched. So in one playbook at DoseMe, we do actually deploy the servers, the web servers, configure them, add them to a load balancer, deploy the relational database service, connect the web servers to the relational database service as well. Okay, so I mentioned before that we're a medical device in many parts of the world and that we have certain requirements in terms of recording the actions that we actually take so that we can be assured of having a consistent production environment. I'm not going to go into great amounts of detail about Jenkins, which was called Hudson, which you can get an Atlassian equivalent to, and there's plenty of other continuous integration platforms out there. But Jenkins allows us to do a few really nice things. We can trigger based on commits. So when we actually make changes to a configuration repository, we can have that rolled out automatically. We can also have that done periodically. In case somebody who I haven't caught yet has logged into a server manually and changed something, I can be certain that periodically his work will be undone. We can also do it as a dependent task. So if a new piece of, an example of that is when we push new code to the dev branch, it triggers Ansible and that code is rolled out onto the dev servers for continuous deployment. And we can also run jobs manually. For instance, applying upgrading all packages on a system isn't something that we want to automatically do. So the way that we do this, and this is, I guess, a trivial example, is that we use a Perl script, a Perl unit test, so just a file in the T directory, in order to test our playbook in Jenkins before rolling it out. And this example that I've put up here is trivial and very, very bad. I'm using backticks. Ben will frown at me and shake his head. But it's a really simple way of making sure that at least you haven't made any typographical errors. And then in Jenkins, we can use the prove command in order to output test harness results in the format that Jenkins likes and understands. You're probably going, but hang on, there's an easier way of doing that that's a little bit more Java-y. We're not a Java shop, and we were doing Perl unit testing in Jenkins anyway, so you kind of stick with what you know, and it works. So following a configuration check in Jenkins, it then triggers a task that runs the playbook. And really importantly for us, because it's the medical device stuff again, which seemed crazy to me when I first got into it, we have a great record. We have a record of changes made to the playbook, by who and when they were made. You'll have that in version control anyway, but in this case we actually have it linked to then when that task was executed. We have an output that gives any changes that are made on the host. We get the full console output of running Ansible. So if we actually do want to run something in Ansible that checks the versions of a bunch of different pieces of software installed on a platform, we can do that, have that output, and then have that stored in the log permanently. And we also get a summary of actions taken. So, for instance, on this unnamed host, there's been 37 things done and 2 were changed. And the other really great thing about doing it this way is that when you've come from a development background and you're used to being able to point to the guy who broke the build and make them buy donuts, now you can do that in a sysadmin context as well. And here's just a screenshot of Jenkins for. We've got 78 builds in UAT at the moment. Or for whenever I took that image, who knows when that was. Okay, so the stuff that you probably won't read about when you're reading documentation. What were the challenges that we ran into? Well, we started using Ansible really early. I can't even remember what version it was at, but it was July 2012. I had a quick look through the Ansible repository. I think that was maybe 0.7. Since then, the syntax has changed a lot. Even how you use a variable has changed from $item to the double braces format. Roles didn't exist back then, so they're a new feature. They've significantly improved the way that you use the language. I guess the challenge for us was staying on top of a fast-moving project. If you're considering whether you're going to use Salt or Ansible today, I probably wouldn't worry about this at all. It really does seem to have stabilised massively. And as I said, still missing support for some features. I'll need to double check about the load balancers in VPCs. And there are some things that you can't do with the relational database servers yet, but you should soon be able to. The other challenge that we have is we can't do continual deployment to production, but that's because we're regulated, not because we can't technically do it. In terms of the benefits, so we're a startup. We don't use Ruby, we don't need to deploy Ruby. That's wonderful for me. Not so great if we ever have to start using it. We don't have to worry about agent deployment. So that's really wonderful. When I deploy a machine on Amazon, I don't need to worry about making sure that there's an agent in the image or that I do a post-install hook to put an agent onto the image. When I deploy a machine, it's got an SSH key and Ansible can talk to it straight away. In fact, as I showed you before, in the same pass as actually deploying the machine. The code is really nice too. So, as I said, I've been working on the VPC module. It seems to be pretty relatively easily extendable, and the code is nice. So that's always great. But most importantly for us, we were a startup. I started using configuration management when we had 2 servers, Dev and UAT. When you've got 2 servers and you've previously been working in a place with lots of them, you know that configuration management is going to be important one day, right? But let's be honest, when you've got 2 machines, you probably don't actually need to do it. You can bumble along without it. But you don't want to get to the point where all of a sudden you have 10 machines and you've got nothing and you have to cram it in and hope that you don't break live systems. Realistically, the major benefit that we've had is that it was very, very easy to start with a dead simple playbook. The first thing that DoseMe ever did in Ansible was make syslog point to the same place. I mean, it's a trivial task. I'm sure that everybody here would be able to do it with very little difficulty on 2 machines. Right? But it gave us something to start in a playbook, get the playbook running across both machines, and then just as we've needed to do more stuff, it's expanded. And I think now we're using 5 different playbooks for different purposes. So it has, if you're wanting to do a startup, pick something that's simple to do simple things in and makes hard things possible, which is kind of the Perl motto as well. But that pretty much wraps up what I've got to say. As I said, you can get the code in order to actually deploy some Amazon instances. So it's a pretty complete example of, I guess, a simple web service talking to a database with a load balancer in front. Just be aware it won't all fall under the free tier because it does use multiple availability zones, but it is all micros, so you shouldn't have too much of a problem with cost. And as far as docs, the Ansible documentation site is unbelievably good, except for some of the return data structures, and the Boto documentation is superb as well. So really, in terms of what you need in order to start deploying entire organisation rollouts onto Amazon, those sites are pretty much all you'll need. And as I said, we'll email out the link to the source code repository. So with that, I'll end and open the floor to questions.
So is Boto basically Amazon Web Service calls wrapped up in kind of Perl Python libraries? Python?
Yeah, so it was originally a Python library in order to do the AWS stuff that their command line clients can let you do in a nice programmatic, easy to reuse way. Amazon since hired the guy who wrote it because it really is that good. Ansible uses it as its way of, because Ansible's written in Python, it uses Boto in order to do all the AWS comms.
I might be wrong, but I think Amazon's new Llama interface uses Boto as well.
Yeah, I think you're right, yeah.
Is that what it was?
Yeah, no, it's like, it's one of those open source projects that you kind of look at and go, okay, wow, they've really done it well, yeah.
So do you back AMIs at all? Okay.
No, so in our playbooks, we just use a standard, well in our case we generally use Debian or sometimes Ubuntu, and we'll just use the stock standard image that's available.
So you're not using any of the Elastic or the, making sure that there's always a server running aspects of...
No, so, well, we have in-house Nagios in order to take care of alerting, but yeah, we haven't gone there yet.
Do you deploy to other things apart from Amazon Web Services, and you use Ansible for that as well?
Yeah, but not for managing the virtual machines. So we have some servers in a rack in town, for instance, where our dev stuff mostly is. And yeah, Ansible logs into those via SSH. That's primarily a function of cost, in that if you've got continually running stuff that's not an actual revenue source, and you can stick it behind a firewall so that it's less exposed, then it is cheaper to do it in-house. But it is much more painful in terms of configuring.
Yeah. So in that way, when you deploy, do you deploy something to that server first and then kind of migrate it up to Amazon Web Services? Is that kind of how it works?
Yeah, so, well, I just moved a site into Amazon last month. So it was pretty much deploy the code version that we needed to do, set up the instances, deploy that, and then it was a case of export the database, import the database, do a redirect until DNS fixed. So that was the extent of the manual stuff, I guess.
Do you use different roles for the pushing to the two different things, or might it?
I have two different playbooks, yeah. So in-house stuff is a different playbook to Amazon.
But it's pretty compatible.
Yeah, it reuses different bits and pieces, yeah.
I've got a couple of questions. Do you use any of the accelerated mode or anything with Ansible? You just use
not yet. So I think it used to be called Fireball mode.
But that's that was different again from accelerated. They re-implemented it a few times.
Yeah,
and now with 1.5, they're doing something back again, just over plain SSH again, I think.
Yeah, they've changed the way that they're doing SSH. They used to use Paramiko, which was a slowish Python library, I think. And now if you've got a version of OpenSSH with Connect Keep Alives or something, they'll use that instead, and that's much, much faster. But we haven't got to the point yet where that's necessary. I suppose if you had, I don't know, a couple of hundred servers it might be, but we're not there yet. So.
Oh, okay, yeah, cool. Sorry, just on top of that as well, the workflow you're doing is something we do very similar on top of OpenStack and private cloud.
Yeah.
And just the example there where you do the booting of the instances via the EC2 module, and then you add it to the group, use that host to put it into the group launch. Does that work? Well, I used to do that, and the thing I found was that that would be good if you were applying the same roles to all the servers, but if you wanted to say, launch me 50 servers, 20 of them are database, 20 roles, do you actually do have different playbooks? Like, I'm interested in
No, so you have to, yeah, I know. Yeah, so what you get back, if you say launch 50 servers, you get one variable back from the launch of that listing 50 server IPs, right? And there's not a nice way, at least that I'm aware of saying take 30 of those and make them web and take 20 of those and make them database. The way that I've worked around it is that I have 2 different blobs of Ansible that launch different sets of servers into different variables, and it's nasty, but do you have a better way?
I wouldn't say better, but what we do is we have one playbook that creates instances, and in the inventory for a particular kind of type of host, we just tell it what playbook to run when it boots up, and it does an Ansible pull on instance creation and kind of bootstraps itself that way.
Yeah, we kind of solved it similar to that. We have a playbook which creates all the base infrastructure. Then we have an inventory plugin which can then talk to your cloud provider again to pull them all down.
Yeah,
and
that's
then merge them with, like, you know, your own groups based off a unique ID or whatever.
Yeah, that's something that I didn't get on or talk about at all today. And the playbook that you'll see is very straightforward. It just creates instances, deploys them. If you keep rerunning it, of course, it'll find the same instances and do stuff on them again. But there is also an Ansible plugin that gives you a list of all of the machines and resources that you're using in Amazon. So if you've got existing instances and resources, which is what I assume you're doing in your second playbook, you can get an inventory of them and then do different things. And I guess you can launch them with different tags. So for those of you familiar with AWS, you can have like key value pairs associated with pretty much everything, and you can in Ansible group or do different things based on that value.
Did you do any sort of analysis on the cost benefits of using AWS versus Jenkins?
Only a very rough back of the envelope one. It's noticeably more expensive
to go AWS.
To go AWS than do stuff in house. But you don't use AWS. Mind you, that was assuming that time is free, by the way, which of course it isn't, unless it's kind of your company, and then not really either. But yeah, AWS is more expensive. It does. I guess for those, how many people here went to Awesome Day or something similar? Only a few. Well, it was a lot of. There was useful stuff there too, but there was a lot of marketing. And the marketing at it all centered around one particular thing, which is you no longer have to rack and stack your servers, right? And it's, I guess the major selling point is that it's easier. I mean, well.
It's also cheap to turn them off.
Yeah, it's also cheap to turn them off. You need to redeploy something. Temporarily, it's absolutely fantastic. So this is how you provision a relational database server across 2 different so across multiple data centers with failover that's totally transparent. Now that's what, 15 lines maybe? Like, try doing that any other way, and the headaches will be, I have done it the other way, and it's quite an intense headache that you get. Amazon provides a great service, but it's not that you can usually do stuff cheaper other ways. That answers that question.
I think it also goes back to what you're saying earlier, is that if you're kind of running something 24/7, then maybe AWS isn't going to be the best bet. But if you've got kind of lots of spikes where you can benefit from elasticity, or just not running things overnight or something, some of those additional costs. You can make a big difference as well. It probably still costs more.
Well, I don't know. There's lots of workloads where it makes perfect sense. So I was talking about still in secret product that we're going to be working with another company on, and it needs 80 CC2.8x larges in a 1-day period every very long. It's scientific computing basically, and those 8XLs are like E2560s with 64 gig of RAM or something nuts. Now you buy 80 of them and see what your budget looks like. when you only need them to use them once every 3 months. So like for stuff like that, yeah, it's very cheap. Okay.